Start.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Syakir Zulfadli bin Masud.
Hi, my name is Rizal Naim bin Muhammad Syarif. I'm from Diploma Computer Science.
1, 2, 3.
Hello everybody, my name is Nujali. Today we're gonna explain our theme is the graph theory and trees. Hello everybody, today we're gonna explain our theme is the graph theory and trees. Trees are graphs that do not contain even circles. They represent hierarchical structures in graphical form. Trees belong to the simplest class of graph. Despite their simplicity, they have rich structures. Trees provide a range of useful applications as simple as family trees to as complex as trees in the data structures of computer science. A connected acyclic graph is called a tree. In other words, a connected graph with no cycle is called a tree. The edge of a tree are known as branch. Elements of tree are called their nodes. The nodes without child nodes are called leaf nodes. A tree with n verticals has n minus 1 edge, which means like 5 verticals, they have the 4 edge. If it has one more edge extra than n negative 1, n minus 1, then it's become a cyclic graph, which is a variation for the tree graph. For the example, in the above example, the verticals A and D has a degree 1, and the other verticals B and C has degree 2. This is possible because for not forming a circle, there should be at least 2 single edges anyway in the graph. It is nothing but 2 edges with a degree of 1.
This is an undirect graph in which any two verticals are connected at most one part. Equivalently, a forest is an indirect cyclic graph. Equivalently, a forest is an indirect graph, all of whose connected components are trees. In words, the graph consists of a disjoint union of the tree. As special case, the order 0 graph, a forest consists of 0 trees. In single trees and edgeless graph are example of forest. A forest is an indirect graph in which any two verticals are connected by at most one part. Equivalently, a forest is an indirect cyclic graph. Equivalently, a forest is an indirect graph, all of whose connected components are tree. In words, the graph consists of. Equivalently, a forest is an indirect graph, all of whose connected components are trees. In other words, the graph consists of a disjoint union of the trees. In special case, the order 0 graph, a forest consists of 0 trees. Single trees and edgeless graph are example of forests. Since for every tree, V minus E equals to 1, we can easily count the number of trees that are within a forest by subtracting the difference between total vertical and total edge, which means TV minus TE equals number of trees in a forest. Forest or directed forest or oriented forest is a direct circle graph whose underlying the direct graph in a forest. In other words, if we replace it directly edge with indirect edge, we obtain an indirect graph that is a circle. Some authors restrict the phrase direct forest to the case where the edges of each connected components are all direct towards a particular vertex or all direct away from a particular vertex. See branching. The graph looks like two subgraphs, but it is a single disconnect graph. There are no cycles in the graph, therefore it is a forest.
Spanning tree. A spanning tree is a subset of graph G, which has all the verticals covered with a minimum possible number of edges. Hence, a spanning tree does not have cycle and it cannot be disconnected. We found 3 spanning trees of one complete graph. A complete undirected graph can have n power of n minus 2 number of spanning trees, where n is the number of nodes. In the example, n is 3, hence 3 power of 3 minus 2 equal to 3. So we have 3 spanning trees are possible. By this definition, we can draw a conclusion that every connected and undirected graph G has at least one spanning tree. A disconnected graph does not have any spanning tree, as it cannot be spanned to all its vertices. Next, general properties of spanning tree. We now understand that one graph can have more than one spanning tree. Following are a few properties of the spanning tree connected to graph G. A connected graph G can have more than one spanning tree. All possible spanning trees of graph G have the same number of edges and vertices. The spanning trees does not have any cycles or loops. Removing one edge from the spanning tree will make the graph disconnected. The spanning tree is minimally connected. Adding one edge to the spanning tree will create a circuit or loop. Mathematical properties of spanning tree. Spanning tree has n minus 1 edges, where n is the number of nodes or vertices from a complete graph. By removing maximum e minus n plus 1 edges, we can construct a spanning tree. A complete graph can have maximum n minus 2 number of spanning trees. Thus, we can conclude that spanning trees are a subset of connected graph G and disconnected graph do not have spanning tree. So, application of spanning tree. Spanning tree is basically used to find a minimum path to connect all nodes in a graph. Common application of spanning trees are computer network routing protocol. C is cluster analysis.
Hi, thank you for watching.
Bye.
Bye. Bye,
Sisi,
uncle.
uncle.
Thank you, uncle. Sisi, uncle.
3.
Hello, everybody. Today, sorry. Tree and trees. And trees are the graph that do not contain even a single circle. They represent hierarchy.
Oh my god, working there. Next, we are going to explain about the general properties of spanning tree. We now understand that tak bisa bro. Next, we are going to explain about general properties of spanning tree. We now know.
Tak. Turun balik.
Civil network planning. Sini pula. Sini lah. Okay.
Okay, start. Start.
Computer network routing protocol. Dah.